We're doing section 9.8, which is factoring polynomials completely. As if you haven't been doing that already.
So what we've been doing.
There's going to be one little new thing today, but most of it you should see as, oh, we're already doing that. Ooh, I get to practice it today? All right. We're going to factor out a common binomial. This is the new thing. Okay, that's enough. You're on radio. Video.
Recording.
Factor out common binomial. Please, I've started in the middle of this problem. Okay, please note that I've started in the middle of this problem. We'll start from the beginning in a little bit, but I need to teach you how to take out a common binomial. You guys have done where you take out a common monomial factor out front. This is a common binomial. If you note here, this x minus 3 is in each term. I've got 4x times x minus 3, and I have 4 times x minus 3. What we are going to do is we are going to take out that x minus 3 as a common binomial factor and write it outside once. And then we're going to jot down what we have left from our polynomial up here. Think about this. If you divide this by x minus 3, doesn't that mean these two are gone? What am I left with? 4x. So put a 4x here. And if I divide this by x minus 3, what am I left with? 4. A 4. And I have a plus sign in front of that 4. So guess what? It's a plus 4. You just created 2 binomials.
That was easy.
Yeah, it really is pretty easy.
At least with the 9.8 was like really hard. I suppose so. No, she said if we didn't do the tricks.
If you didn't work with some of the other stuff, 9.8 is just, you're going to wish you had learned it all. Okay? All right. So notice that when I divide each of those terms by that binomial, I've got that x minus 3 sitting out front here. I have to write down the other parts of the terms that are left. Are you guys okay there? Why don't you do this one then? Oh, no, we got to talk about this one. I can't just have you do this one. Take a look at the 2 binomials that are up there. What do you notice about them? What do you notice, Grant?
Inside the parentheses, the numbers are good, and we realize the number outside the parentheses are big.
Okay. Especially what Grant said first. Inside, the numbers are flipped around, and therefore the negative signs are on different terms. So these are called opposites of each other. Okay. When you have opposites of each other, you have to make them be the same. Hint, hint. What could you take out of the second binomial in order to make it look like y minus 5? What do you think, Josh? A negative. So I'm going to rewrite this as 2y squared with the y minus 5. And I'm going to put a plus 3 out there because I will now write this as y minus 5. Why did I put plus 3? Why did I put a plus 3? Luke?
Because you were dividing by a -1.
Not dividing, I was multiplying by a -1. I took a -1 out of this term here. I took a -1 out of here, and therefore this became a positive 3, because that -1 times the -3 gave me a positive 3. Now I have 2 factors that are the same. Now you can go through and do this one. All right, do I have a volunteer to tell me their 2 binomials, please? Go ahead, Tyler.
Y minus 5, 2y plus 3.
Let's make that 2y squared plus 3, and then I'll be just fine with it. Okay. Adam.
Why is it y minus 5 squared?
Because, let me give an example here. Take out the GCF for me. What's the GCF between 3x squared and 2x? How can you write x squared?
There's only one x.
There's only one x that they each have in common?
Yeah.
There's only one y minus 5 that they each have in common. Does that answer your question? Okay, awesome. Now, we are going to factor by grouping. You needed to know how to take out a common binomial factor in order to be able to factor by grouping. You use this when you've got 4 or more terms that you have to factor. Okay, so jot down x cubed plus 2x squared plus 8x plus 16. We use this when we have 4 or more terms that we have to factor in a polynomial. Group them so that they're highest degree to lowest degree. They are up here. Then we're going to look at these two terms, the red two, and then we'll look at the green ones in just a moment. Looking at the red terms, take out a GCF. What's the GCF that's going to come out of those two terms along the way? Jack?
1. Well, x.
Just an x?
1x.
Just one x?
No, 1x squared.
1x squared. So they each have at least x to the second. And what's left when we take an x squared out of each of those? Jake? X plus 2. Jack, you okay with that?
Yeah.
All right. Then look at what I have underlined in green and take out a GCF. What's the GCF that's going to come out of 8x plus 16? Andrew? 8. Now, Andrew told me 8, so I'm going to write plus 8. Had he told me a negative, I would have made sure to put a negative in front of it. Andrew, what's left?
X plus 2.
All right. Do you notice anything about the two binomials?
It's the same.
Oh, they better be the same or this isn't going to work. Okay, they better be the same. So now factor out your two binomial, your common binomials, factor them out. How many times do we write them? Once. So I write down x plus 2. And what are we going to write as what is left in the other part, please? Michael?
X squared plus 8.
X squared plus 8. Oh, by the way, look at x squared plus 8. Can I factor it any further? No GCF? Is it a difference of squares?
Yes.
Okay, there's two things wrong with it being a difference of squares. Number one, is it a subtraction problem? No. And number two, is 8 a perfect square? Then it's not a difference of squares, ladies and gentlemen. Okay? I have to have square in both of these spots, and I have to have subtraction for it to be a difference of squares. Why don't you and your partner do this one? Work at the board is correct, R plus 4 and R plus S. Any questions there for what you see? Josh?
Could you have the two numbers inside the parentheses flipped around?
So tell me what you want.
Like, could you have like 4 plus R and S plus R?
Yes, technically yes. You know, that's commutative property of addition. Okay? Anybody else? All right, then let's go on to this next one here. X cubed minus 10 minus 5x plus 2x squared. I have a problem.
They're not in the highest to lowest.
They're not from highest to lowest? Ah. So use your commutative property and write them from highest to lowest degree. And then do you think you could factor by grouping from there? Absolutely. Go ahead and do that. We'll get some more people up to the board. Up here we have x plus 2 and x squared minus 5. Is that done? X plus 2. Can you factor anything else out of it? No, it's to the first power. X is to the first power. X squared minus 5 is to the second power. So you should always look at something that has an x squared in it and think, am I done? X squared minus 5. First of all, binomial or trinomial? Binomial. Addition or subtraction? Ooh, is it a difference of squares?
No.
Why not?
Because there's a -5 and it can't be. Yeah, 5 can't be squared.
5 is not a perfect square number. That's the reason. 5 is not a perfect square. If I had x squared minus 16 up there, could we go on and work that a little bit further?
If you do.
Yeah, absolutely, you have to if that is there. Okay. If this were x squared minus 16, you would have to go on and make this x plus 4 and x minus 4. You'd have to finish factoring. Remember the name of our section today? Factoring completely. Here, yes, you factored, but this would have to keep going to this. X squared minus 5, is it done? Absolutely. So we're okay here. But if I had x plus 2 times this x squared minus 16, I would now have 3 factors in my answer in the end. Okay, just FYI, hint, hint, wink, wink, test. Okay. Evan? We're okay? All right. Let's see here. Do we need 3 more of these, or are we doing good?
How would you do that? The top one. With because there's no second number, so would it just be plus x?
No, what number's sitting in front of x minus 2 on that second term, ladies and gentlemen? A 1. So you will have an x minus 2 and an x plus 1. So maybe we did need that one. It's a good one to have. Okay, so are we okay? Go on. These are the things that you need to think about to factor completely. Every time we start doing homework, I talked to you about GCFs. So you must find the GCF, take it out if you can, put it out front. Then, look to see if there's a pattern. You're looking for that difference of perfect squares or having a perfect square trinomial. Those are the patterns we talked about yesterday in class in 9.7. If it's not one of those patterns and you've taken out any GCF that's possible, then you have to factor the old-fashioned way. Guess and check. Now, if there are 4 terms or more, then you factor by grouping. So 4 or more terms, you're going to factor by grouping. But if it's a trinomial, you're going to try and factor it into 2 binomials. Okay? That's just kind of the order of things you should be thinking about in your head. Can I take out a GCF? Ooh, is there any special pattern that I can just write the answer down? Okay, now I got to do some work. I either got to guess and check or I have to factor by grouping. A polynomial with integer coefficients is factored completely if it's written as a product of unfactorable polynomials with integer coefficients. That's why I asked, is that x squared minus 5? Are you done with it? If it was the x squared minus 16, I could still factor it farther. So a polynomial is factored completely if it's written as a product of unfactorable polynomials, and all of them have integer coefficients. We're not going to end up with any fractions or decimal as our coefficients. So let's factor this one completely. Factor it completely. We've got a bunch of these to do where we're going to factor it completely. You say we can't do this one? There's no way we can factor it? Okay, let's make sure here. We've got x and we've got x, and we've got a 3 and a 1, right? Okay, it has to be 1 positive, 1 negative, right?
Yeah,
Nothing's going to work,
You get
huh?
-2.
Gosh, I wonder what we could write down that would tell us. that it's unfactorable.
Okay, we should have done that one, guys.
What's this?
That is unfactorable.
So you knew we were on something.
Yeah.
Just trying to trick us.
No, I'm checking, yeah. I was waiting for the question. Is there any time that they're unfactorable?
Is there any time they're unfactorable?
Yeah, just like now. Okay. All right, let's go to this one instead then. Okay. Hopefully you can do this one better. Back to the front, please, ladies and gentlemen. The first thing you do is take out a GCF, so that's that 3x coming out front. And you're left with x squared minus 7x minus 18. You only use factor by grouping if you would have 4 or more terms. And that's when the factor by grouping works really well. The deal is I've got that x squared minus 7x minus 18, and now I have to factor it. It's not a perfect square trinomial because 18 is not a perfect square number. So I start my 9.5 process. Guessing and checking. All righty. Then I look at x minus 9, x plus 2. Every one of these x's, what's the exponent on the x? 1, then you're done. How about this one? Now, this is the correct answer. That's where you should have stopped. This d squared plus 3, is it a trinomial?
No.
Is it a difference of perfect squares?
No.
It's not a subtraction problem, and 3 is not a perfect square. So you can't go on any further. Now, just for the sake of argument, if we would multiply these things together, what do we get?
Squared plus 3.
Plus 4d plus 3. I get a 4d in the middle. There's no 4d up there.
Yeah, that's what I was thinking. That's what I thought it was.
Okay. So this goes away. All right. This should be your only answer. You guys take out a GCF? That was it. That's all you could do. You factored completely. Oh, now, Luke, you asked me earlier, is this harder?
Yeah.
No? Okay, some people are saying yes. Solve.
Oh, that's.
This isn't hard?
No.
All right, go ahead. Solve it. Sorry, I was just checking the next one. All right, let's come back together with this, please. I'm recording. What do we need to bring over?
Negative 36x.
Okay, so 2x cubed minus 18x squared plus 36x equals 0. That's where we need to start. Get 0. Now, what are you going to pull out as your GCF, please?
2x.
Let me know what's left, Evan.
X cubed
X what?
squared.
Squared.
Minus 9x plus 8 equals 0.
All right. Now, when I look at this, I go, trinomial. Does it fit one of the patterns? Perfect square. Is 18 a perfect square? Nope. Go on to the next step. Now I got to factor the old-fashioned way. So I have a 1 as my leading coefficient. What numbers can I put in for 18? That'll add up to be a negative 9.
Minus 6 minus 3.
Minus 6 minus 3 equals 0. And have I factored them all the way?
No.
Oh.
We factored them.
Okay, I factored them all the way. That was my question. Did I factor them all the way? Yes. Now what do we still need to do?
Solve.
Solve. So what are we going to take care of?
So,
So, hey, guess what? Here's a variable. Do I get to throw away that too?
yeah.
No.
No, you
There's a
don't.
variable.
No, there's a variable there. What's 0 divided by 2? 0. So 0 is one of my answers. X minus 6 equals 0. X equals 6. X minus 3 equals 0. X equals 3. I got 3 answers for this problem. You know what? I knew that before I began that I was going to have 3 answers. Because the highest degree was 3.
So how's yours like 5?
I'd have 5 answers. Jack,
I got x equals 1.
where'd you get x equals 1, sweetie?
Well, I divided everything by x.
You divided everything by x. Don't do that. You just threw away an x.
Yeah, but then I had x squared minus 9x equals 2. I mean, nothing about x squared.
Please stop. I can't hear.
And so,
You can't divide by x. You're throwing away one of your solutions.
okay,
Okay? Don't do that.
okay.
Okay? You're throwing away one of your solutions. All right? You could divide everybody by 2. I don't have a problem with that. But not 2 and the x. All right? All right. Adam.
So like with how many answers there are, would it just keep like with 2x to the 5th, you'd keep being able to divide it down 4?
Technically, yes. Okay? Grant?
Yeah, I'm confused now. So what would the one, because usually we just like throw away that short x.
Remember, I always said there's no variable with it. Now I have a variable
Oh,
with
so the
it.
other ones, it was just like 2.
It was- Exactly. 2 equals 0. False statement.
It's not a true statement.
2 times x equals 0. Oh, I can solve for x.
Okay.
All
So
right.
if there's ever a variable outside with it, then we'll have one.
I'm gonna, no, I don't want to skip over this one. Let's go ahead and quickly talk about it. All right, is there a GCF to take out of this, please? Is there a GCF to take out? Grant?
C.
C. Tell me what's left then, please, Grant.
Then it's C to the second minus 7C plus 2.
Now, this trinomial that's left inside the parentheses starts with the perfect square. Does it end with a perfect square? No. That means that I'm going to be factoring it like this. So I'm going to have C and C. What else am I going to put in there, Allie? -3 and -4. Then set each of the factors equal to 0. Each of the factors equals 0. Hey, C equals 0. Can I have that as an answer?
Yep.
Absolutely. C equals then here 3 and 4. So I have, again, 3 answers. Don't just throw C away. It has to be set equal to 0. It's a variable.
What if 12 was perfect square? Like, it was gonna be
Let's say we had C squared minus 12C plus 36. Then I'd have my C minus 6 quantity squared. Okay, I'd do the factorization of that. All right, British method, here we come. I want a good problem here. 10 squared, or 10x squared plus 19x plus 6. This is the British method.
So, can we do this?
Pardon me?
Can we do the British method?
Instead of
Yes.
and check.
Yes, you can use the British method.
So
Once
on
I've
the-
taught it here
On
now.
our test, we can do this.
You can. You can. Now, notice this is just an ordinary trinomial, isn't it? Can you take out a GCF?
No.
No, but 10's got a couple sets of factors, 6's got a couple sets of factors. So technically, there's like 8 different ways that you can combine things to make things work out here. And for some people, that's a little bit, a lot of work, shall we say. So here is the British method. You're going to take A times C. So that's, in this case, 10 times 6. What is 10 times 6? 60. And what you're going to do, and you're still going to look at factors, so I'm going to start looking at factors 1 and 60, 2 and 30, 3 and 20. What else? Does 4 go in there? 4 and 15. How about 5?
Yeah.
5 and 12. How about 6? How about 7? 8, 9, and we come right back to 10. Okay, find which set of factors up here adds up to B that has a sum equal to B. Which one has a sum equal to B? Jack?
4 and 15.
Okay, so what I'm going to do is I'm going to come over here and I'm going to write 10x squared. And then we added them up to be 19x. So I'm going to write plus 15x plus 4x. Those are the two numbers Jack gave me. And then plus 6. Do you agree 15x plus 4x is 19x?
Yes.
All right. Now, honestly, it doesn't really matter which way you write them, but I usually try to look at my coefficients and think, is there something that those two have in common? Because they're going to have an x in common no matter what. Now we're going to factor by grouping. So what comes out of 10x squared and 5x? A 5x. What's left?
2x.
Plus 3. What comes out of 4x plus 6? A 2. What's left? Okay. What's the common binomial? 2x plus 3. And what's the other binomial? 5x plus 2. No guessing, no checking.
That's a lot. Wait, how'd you get the second?
How'd I get what second?
Plus 2.
The plus 2 comes out of these two
Oh,
terms. Okay. Should we try another one?
yes.
All right. Oh, let's see if I can't find a harder one. This one looks nice. 21 w squared plus 8w minus 4. All right, so multiply a and c together. What do you get when you multiply a and c together? 84, and that's a negative 84, right? Okay, so now I got to think of the factors that give me 84. 1 and 84. 2 and 42.
3 and 28.
3 and 28.
Yeah.
Yeah.
Okay. How about 4?
4 and 21.
4 and 21. How about 5?
Nope.
6.
Yes. 6 and
6 and what?
14.
14. How about 7?
Yeah.
Yeah. 7 and 12. How about 8?
Nope.
About 9? 10? 11? And we're back up to 12. Now, I have to add them together and get a positive 8, but one of the numbers has to be negative. So where am I going to put the negative? Smaller number. Negative 6 and 14. So when I write this over here, I'm going to write 21w squared. And now will I write minus 6w? Or shall I write plus 14w first? Plus 14. And then minus 6w and minus 4. Okay. Start doing your factor by grouping. Grant?
Wait, how can we write the 14w first?
They chose to.
Oh, it doesn't.
I'll do it down here the other way and show you that it turns out the same. Sometimes one way just works a little nicer than the other one. Okay. So what are we going to take out of the first two, ladies and gentlemen? 7w left with 3w plus 2. What are we going to take out of the other one? Negative what? 2. And we're left with? Alrighty. So we got 3w plus 2 is one binomial. What's the other one? Alrighty. Down here, what would I take out between 21 and 6? 3 and a w. What am I left with? Minus 2. What are we going to take out of 14 and 4? Take out a 2. What are we left with? 7w minus 2. And we're going to get the same thing, aren't we, ladies and gentlemen? So you can see, Grant, it doesn't matter, but sometimes the only thing you'll be able to take out is the common variable or a 1 as a common factor or a negative 1. Okay? What do you think of that?
I like it a lot.
You like that? Okay, they don't teach it that way in Algebra 2.
Why not?
Just because it's not the traditional way to do it. And a lot of people don't know it. I never learned it in high school. I learned it once I started teaching. Only because I read it in the book. Ooh, what a good idea to read the book once in a while.
That's
A kitchen drawer has a volume of 768 cubic inches. The dimensions of the drawer are shown. Find the length, width, and the height of the drawer. How do you find volume of a rectangular prism? Tyler?
Length times height.
Length times width times height. So I've got W times W plus 4 times 16 minus W, all equal to
768.
768. Oh, what are you going to have to do on the left-hand side? Ooh, FOIL. Hey, we haven't done that in a while. Let's FOIL together. Let's FOIL the W plus 4. And could I make that negative W plus 16 be the same thing? Yeah, you can. FOIL that together. And then I would take the W inside. That's how I would do it personally. Okay, after you FOILed. So far we have this equal to 768. And what do we have to do with the W? Multiply it inside. So tell me what we got.
W squared.
No, negative W cubed, and then 12W squared, and then 64W. And what do we do with that 768? Bring it on over. Now comes subtraction. Look at that. Isn't that beautiful?
No.
Oh, wow. So, four terms. Is there a GCF I can take out?
12.
Good luck. There's no 12 in the first one. First term. Can't take a W out of all of them either.
Oh my gosh.
So what are we going to have to do? Factor by grouping. Factor by grouping. So what are you going to take out of these first two?
W squared.
W squared, what are you left with? Negative W
Square.
plus 12.
Oh, it's
Okay. Wouldn't it be nice if we could take out a negative W squared?
and then make that.
No, but that's just a negative 1 there. We could take out that negative out front, and that would make that a positive W and a minus 12. That would make life a little easier, wouldn't it? We took out a negative 1 and a W squared. What about the 64W minus 768? What can we take out of the two of those?
64. Yeah.
64, really?
12.
12 times? Wouldn't that be nice if that's how it actually works? So now I've got a W minus 12 in there. So now I have negative W squared plus 64, and I have W minus 12 equals 0. Okay, let's write this like we're used to. 64 minus W squared. Can you rewrite that? Is it done factoring?
No.
8 is 64 perfect square?
Yeah.
How about W squared perfect square?
Yeah.
So how can I write this? What'd you say, Rachel? 8 minus W and? It comes up to be 2 binomials.
Oh, and then
It's 8 minus W and 8 plus W
Oh.
times the W minus 12 equal to 0. So what? I've got 3 different answers I'm going to have here, right? What's one of them going to be? 12 is going to be one of them. I've got 8 plus W. What's W going to be on that one?
8.
Negative 8. And I've got 8 minus W equals 0. What's W going to be? Positive 8. So I've got 2 answers here that I can actually use.
Actually, wouldn't I win on the left? Because when you have the divide by negative 1,
Why do you know?
Well, you take W over, it becomes positive W.
you can't have negative length and
No, I know, but which one is it?
Which one is it? Find the length, width, and height of the drawer. Could I have a 12 by 4 by 16 drawer? putting 12 in for each one of those.
We have to see.
Now let's put in the 8. Could I have an 8 by 12 drawer?
It's the 12.
Yeah,
Yeah.
it's the top one. 12 times 4.
Why
I
are you
agree
saying
with-
it's the top one?
We times them together.
12 times 4 times 16, how much?
768.
8 times 8 times 12, how much?
768.
It could be either.
2 answers.
Oh.
There are two different drawers.
I could have 2 different sized drawers.